So here is another question on energy of simple harmonic motion. So it is given that a small mass of 0.2 kg is attached to one end of a spring and it produces an extension of 15 millimeter. Okay, the mass is now set into vertical oscillations of amplitude 10 millimeter. We have to find the time period of oscillations, the maximum kinetic energy of the mass, the potential energy and kinetic energy when the mass is at the 20 millimeter point. Okay, so what this thing is saying, that we have, okay, a mass of 0.2 kg which is connected to a spring. It is hanging vertically. Mass of 0.2 kg and it is already an elongation of 15 millimeter. It is elongated already, this, okay, this position up until this point. So this elongated position is the equilibrium position, okay, with the gravity force acting downwards. Okay, then it is also said that from this equilibrium position, the elongated position, the 15 millimeter point, it is set into vertical oscillations of amplitude 10 millimeter. That is, from this point 10 millimeter downwards and 10 millimeter upwards. Okay, this. So the downward, when it travels 10 millimeter, it is 15 plus 10, 25 millimeter, and upwards when it travels 10 millimeter, it becomes 15 minus 10, that is 5 millimeter. These are the two extreme points. Okay, you understand? This is the equilibrium position. Okay, this 15 millimeter point downwards, this is the equilibrium position. Okay, 15 millimeter. From here it undergoes vertical oscillations SHM of amplitude 10 millimeter. So amplitude is 10 millimeter. The equation is y a sine omega t. Now we know that when something is connected to a string, a spring type, spring mass arrangement, there will be a restoring force. So that is equal to K and Y, where Y is the elongation produced by the spring. Here the force acting is downward gravity force. So the spring constant will be the gravity force divided by the elongation Y. So here gravity force is mg by Y equal to 0.2 kg into 9.8 meter per second square by Y, which is equal to 15 millimeter, that is 15 into 10 to the power minus 3 meter. So it is coming around 130.67 Newton per meter. This is the value of the force constant or the spring constant, okay, K. Now first it has been asked to find the time period of oscillations. Time period of oscillations, that is equal to 2 pi by omega, the angular frequency. Omega we have to calculate, that is equal to root over of k by m, which is equal to root over of 130.67 by 0.2, which is equal to, it is coming around 25.56 radians per second. That is the angular frequency. So here it will be 2 pi by 25.56. It is coming around the time period, rounding it off, it is coming around 0.25 seconds. That is the time period. Next, it has been asked to find the maximum kinetic energy of the spring mass system. So here kinetic energy will be maximum kinetic energy, which is equal to 1/2 mv square. It will be maximum when the velocity will be maximum. So first we have to find V max for SHM, which we all know it is equal to omega into A, where omega is the angular frequency, A is the amplitude. Omega we have calculated 25.56 radians per second, and amplitude it is given 10 millimeter. Okay, it is set into vertical oscillations of amplitude 10 millimeter. So here it is 10 millimeter. By mistake don't write 25, it is wrong. 15 millimeter is the equilibrium position. Okay, 15 millimeter is the equilibrium position. From here it is undergoing, from this 15 millimeter point, it is undergoing vertical oscillations of magnitude or amplitude 10 millimeter. That is 10 millimeter downwards maximum it can go, and 10 millimeter upwards from this 15 millimeter point. So the two extreme points are 15 millimeter and 25 millimeter positions, but the magnitude, the amplitude is 10 millimeter. So by mistake don't write 25. Okay, so it is 10 into 10 to the power minus 3. Okay, this omega A. So the maximum velocity, it is coming around 0.2556 meters per second. Here if we put the value Ek max, that is equal to 1/2 into 0.2 mass. V max is 0.2556 whole square. It is coming around 6.5 into 10 to the power minus 3 joules. This is the maximum kinetic energy. Then it has been asked to find the potential energy and kinetic energy when the mass is at the 20 millimeter point. This is very interesting. It is said that the mass is at the 20 millimeter point, which means somewhere around here, the 20 millimeter point. So here what you will take, the value of y. Okay, the value of the y, the instantaneous position. Here if you take y is equal to 20 millimeter, it will be wrong. The position of the object is 20 millimeter, but in terms of the SHM motion, the SHM, considering the SHM amplitude, it is 15 millimeter, which is the equilibrium position. From there it is 20 millimeter, that is plus 5 millimeter. Okay, from this it has moved 5 millimeter here or downwards to reach 20 millimeter. So here we will take y is equal to 5 millimeter, not 20 millimeter, to find the potential energy and kinetic energy. So here the potential energy will be 1/2 k y square, which is equal to 1/2 into k, which we have calculated 130.67 into y, which is 5 into 10 to the power minus 3 whole square. So it is coming around the potential energy, it is 1.6 into 10 to the power minus 3 joule. Okay, and the kinetic energy, which is 1/2 k a square minus y square, equal to 1 half to 130.67 into a square, which is the amplitude maximum, which is equal to 10 into 10 to the power minus 3 whole square minus 5 into 10 to the power minus 3 whole square. It is coming around 4.9 into 10 to the power minus 3. Okay, this. So here this is the kinetic energy, this is the potential energy. Now here if we add them together, if we add the potential energy and the kinetic energy, the total will be equal to 6.5 into 10 to the power minus 3 joule. Okay, this is the total energy. Here also, when we calculated the maximum kinetic energy, we found out it is 6.5 into 10 to the power minus 3 joule. Kinetic energy is maximum when potential energy is 0. Sum of both is equal to 6.5 into 10 to the power minus 3 joule, which is equal to the total. And here at y is equal to 20 millimeter position, which is from the SHM point of view, it is 5 millimeter instantaneous position. Here the sum is also 6.5 into 10 to the power minus 3 joule. So very important point which we have discussed a lot of times before, the total energy throughout the SHM motion at any position is constant. So here when the kinetic energy was maximum, it was also the total energy 6.5 into 10 to the power minus 3 joule, and here at the instantaneous position from SHM point of view at 5 into 10 to the power minus 3 meter, 5 millimeter or 20 millimeter below the equilibrium at the 20 millimeter position, it is also the same. Okay, and another important point, when it is given that the mass is at the 20 millimeter point, so here it is 5 millimeter below the equilibrium position, 5 millimeter below the equilibrium position, which is 15 millimeter. So when you are putting the value of y, you should always put it 5 millimeter, not 20 millimeter. Okay, because the equilibrium position is 15 millimeter, not 0 millimeter. Okay, the equilibrium position is this. So this is the thing. Okay.